I was going to talk about just a handful of real-world examples where you might want to use graph theory to study the problems. We already talked about the bridges of Königsberg and how bridges could be modeled using graph theory. We also talked about one-way streets and just how you could use streets in general to model in graph theory here. But what if you don't want to do that? What if instead you want to say look at cities? So for example, if we're trying to travel from LAX to New York City, we could take a plane, and maybe I don't know, there's one Delta or something and United or whatever other airlines that are out there. Maybe there's multiple connections between them. On the other hand, what if there's another city in between? I don't know, let's say St. Louis. And maybe you can go from LAX to St. Louis, but maybe you can't go between St. Louis and New York City. I don't know. But studying situations where you're connecting cities with plane or with cars or with trains, whatever connection you want to have, all of these are things that people do when they're trying to decide, okay, well, we have a problem here. We can't get from New York City to St. Louis. How can we solve this problem? Do you want to have another plane route, or do you want to make sure that there's a city in between them, maybe, that you can then have a layover there and go on? So the people that run the airlines, they ask themselves these questions. They look at these types of graphs and they try to see, how do I want to connect these different cities? So that's one way of looking at things here. Another very different example is something called a friendship graph or an associate graph. This would be something like in Facebook or whatever. So let's say one person has a Facebook profile, and then they connect it to, I don't know, this person and so on, and maybe TC and Casey are connected, and TC and AR, but maybe Casey and AR are not connected, they're not friends. So the idea is you would look at these types of connections here and get information about that. So in fact, companies like Facebook and Google, they definitely look at these connections and they try to use this to sell information about you and sell advertising. So let's say, for example, it sees you have a bunch of friends together that have similar interests, and an advertisement on one person actually worked out, they bought the item, then maybe they would make sure to show that same advertisement to all the other people in that friend group, because it might have a higher chance of actually being sold. So knowing who's connected to who can be very valuable data for companies that use that. That's called a friendship graph. This other one here is kind of similar to a friendship graph, and it's maybe not used as much anymore now that we have the internet and emails where you can just email everyone trying to get a hold of. But back in the day, let's say you had, I don't know, so this is something that happened to me as a kid. I was in a soccer league, and you have a bunch of different teams, and you have the captain of the team that runs it, the manager, whatever, or the coach, whatever you want to call them, and then you have all different people on the team. And let's say that there's some bad weather one day and they decide to cancel the game. And the person that decides that is the commissioner, the person in charge of the whole league. We'll call them, I don't know, number one. And maybe there's 4 different teams that are all playing that day. So team 1, team 2, team 3, and team 4. And what might happen is the commissioner, the person deciding to cancel the games, he would call all the team leaders, say the coach or whoever it may be. And then the coach, they would then distribute that information to the people on the team. But maybe the coach doesn't want to call 15, 20 different people's parents. That might be a lot of work. So maybe the coach set up what's called a calling tree or a dialing tree beforehand. And so we have all these different individual people here. And then below that, we have all the actual members. And so maybe the team captain calls maybe, I don't know, 2 parents. and then each of those calls 3 people, and so on. And the idea is, instead of having one person have to call 50 people to let them know the information, they can distribute that to a smaller group, and each one of those smaller group can then call someone else, and so on and so on. It makes it a lot more efficient to spread information around. Again, that specific example isn't super applicable right now with the internet, and you can just send one mass email. However, it is still useful for different things. For example, let's ignore that we're talking about calling here. Let's talk about a company, and you have the CEO on top, and then maybe you have people like the CFO and the COO below them, where they give them direction. And then below them, they have the managers and the VPs and all the other people in the company. And there's usually a very strict contact order. Usually, the CEO makes a decision. He doesn't go down to the person in the mailroom and tell them what's going on. No, the CEO tells the person next down the line, and so on, until eventually that new directive gets down to the person in the mailroom. So it's important to have this connection and study how it's working, because you can maybe see problem areas in your company where messages aren't getting to who they're supposed to get quick enough, and that's causing issues. And one thing that you may or may not have experienced in your life yet is that when you have a large corporation, if you have a breakdown in communication, that can cost lots of money and lots of hassle to try to fix it. And so keeping an idea on a structure like this and finding its weak points is definitely something companies are interested in. So here were just a few different examples of real-world graphs that you might use them for. There are tons and tons more out there. Feel free to Google examples of graphs, and you can see more of them. But we're going to next move on to looking at properties of these graphs and seeing what we can, problems we can solve with them.